Well, good afternoon. I'm John Marsliff,
I'm Tony Angel.
and we're going to talk to you a little bit today about our recent book, Gifts of the Crow. Our idea is to show you some of the things that these amazing birds, the crows, ravens, jays, and magpies, can do, and try to explain them a little bit by looking at how the brain of a bird handles the vast amount of information it takes in each day.
One of the things that it seems to be appropriate to say is how we got started in this. And I think both John and myself have been fascinated with corvids since we were kids for some of the same reasons that we explore in the book, because we saw such a high level of intelligence, rather amazing behavioral dimensions to these birds that set them apart from other species. So that in the way of background on myself and to some degree John, who is of course going on with his specific studies in these particular subjects, will help you understand where we're coming from.
Yeah, my background is more looking at these animals from a scientific standpoint. So I've been interested in birds for a long time, but all of my graduate research and scientific investigation has revolved somehow around corvids, be they jays or crows or ravens. All of those have interested me and their behavior and their ability to solve problems and get into trouble, really, and pose difficulties for other species, endangered species, or humans, has been of interest to me.
One thing I would add, John, in terms of my background and interest as an artist, I found these particular subjects to be without limits when it came to the possibilities of interpreting them in line or in color or in carving. Their behavior, their gestures, their action, they're very beautiful, even though many of their species are monochromatic. They're a single color bird, although, of course, a lot of the tropical species are very colorful. Nevertheless, I was interested artistically as well as a naturalist approach to these subjects.
Yeah, just the somber nature of their plumage is quite striking and so different from other birds. But what got us really going with this latest book is that we'd been giving talks and listening to other people tell us about all these amazing things that crows and ravens have done. Some of this is well documented in the scientific literature, but a lot of it is fairly anecdotal in that they're rare events that few people are going to ever be able to witness in their lives. So we communicated with a lot of individuals, much like yourselves out there, about the sorts of things they've seen crows and ravens do, and we try to relate these in the book. And we've heard of all kinds of things. I mean, every day it seems like we learn something new, but an awful lot of the information we've heard has just been mind-blowing to us. I mean, we've heard of these birds committing murder or smoking cigarettes.
Well, just today, John, I got an email from a fellow who had lived in Alaska and had stepped outside because he heard a cat meowing. Meow, meow. And he looked around, didn't see a cat, but he did see the lady next door come out with a big plate of cat food, put it down on the snow covered ground, and as she stepped back in the house, down came a raven that was standing up on the telephone pole, meowing like a cat.
So using that trick perhaps to get food from this woman. We've heard lots of other use of voice. We'll talk about some of those and other sorts of problems that individuals have had with these birds that have really challenged them and caused them to think about what really might be going on in the brain of these birds.
One of the best examples that has recently come before the public in general is the New Caledonian crow and the way in which it effectively employs tools. And I think as a way to get started, we might want to show that video. We won't be able to talk over the video, so as we go into it, watch what the crow does to approach the retrieval of food and initially trying to apply friction to the edge of this little rim on the bucket. But it does solve the problem.
Yeah, and what you'll see here is a video of a New Caledonia crow in a lab situation. It's a wild bird that was caught and is in some of the labs at Oxford. Alex Weir gave us this video to show you, and it really is phenomenal in terms of getting you to think about the sorts of things these birds are possible to do. So here's Betty, the New Caledonia crow. All right, so she was able to solve the problem of getting the food out of that tube, and did it in a very novel way, not a way that other animals would typically do. Would you agree?
I would agree. Yeah, bending that wire and hooking it and staying with it, solving that problem, and pulling it up out of the tube.
Yeah. Now, it's not so unusual that this bird would actually make a tool to solve a problem, because again, this is a New Caledonia crow. It's a distinct species of crow found on the islands of New Caledonia where there aren't woodpeckers, and so it routinely makes tools out of sticks and bends leaves to make hooks and peels away parts of the leaf, leaving skewers and hooks remaining, so that it can access these foods that are unavailable to animals on the mainland, where there are woodpeckers doing the same thing with their incredible bills.
It always struck me as being rather remarkable that they not only make 4 or 5 different kinds of tools for 4 or 5 different tasks, but they store the tools
For later.
for later and then retrieve them. Oh, I'm going to need something that can have a little burr on the end that I can agitate an insect, a larva, down underneath the bark. It'll grab hold of it, and then I can bring out both the stick with the burr on the end and the larva as well. So it definitely demonstrates clearly a tool applied to a specific task that's in the mind of the bird.
Right. Now, given that we're talking about the mind of the bird, let's look at where the brain of this bird stacks up relative to other corvids. So we're going to look at a couple of skulls first, just to give you an indication of where a crow brain rates relative to another similar bird.
I'm holding it up to the screen here, but on the left of the screen, as you look at it, you're going to see this crow. There we go. Everything is a little bit backwards. And then as we bring in from the other side the skull of a pelagic cormorant, there we go. Now you can feature it on the scale. You can see that the crow is probably twice as large as the pelagic cormorant, even though the cormorant is a bigger bird than the crow. It weighs a little bit more, wingspan is a little larger, but that cranial capacity of the crow is very remarkable.
Huge. Looking at it from straight down, you can see a large area where the eyes would be of the bird. They're very visual, but they have a huge brain case and a large brain within that. So we're going to pull up a graph next, and this graph is going to show you how brain size and body size are related in animals. It's a very obvious, typical relationship. The bigger animals have bigger brains. They're physically larger, need to coordinate many more signals around their bodies, and a larger mass of their bodies, and perhaps even different sorts of information. So big animals have big brains, but some animals have exceptional brains for their body size. So what you're going to see on this graph are a series of lines that are parallel, and those are the average body size to brain size relationships for different groups. We've got fish and birds and mammals and primates as lines on this. And then you'll see some dots, and those dots, and especially one in red, will be the New Caledonia crow. The other dots are the other corvids. And just notice that they're well above the bird line, and in fact, they're right up on the primate line. And you can take some comfort when you look at where humans are. We're above the primate line, but these crows and ravens are really, really exceptional for birds in having big brains for their body size. They're really much more like small monkeys than they are typical birds. And you'll see a couple other birds that have big brains also there, and those are the macaws, or the large parrots that you may be familiar with. So here's the graph. Okay, so hopefully you get the point that these are really outliers in the bird world that have large brains. But there were a couple of other keys on that slide for you. They're also very social animals, so they can learn from one another about things in their environment. They don't have to experience and go through the trial and error process all by themselves. They can take advantage of others' experiences.
One thing I might say at this point is that some of these graphs and tables may be a little bit difficult to read. We're not entirely sure, but they're in the book. All those details and then some you can reference. But what this provides, we think, is a basic background of what will follow here. this neurobiological matter is somewhat essential to some of the examples we provide later.
Yeah. And so let's take a look. It's not just their sociality and their big brains, they're also long lived, these animals. So they, a crow might live 15, 20, 30 years in the wild once it gets past that first really dangerous few years where many of them don't survive. But if they survive to become a adult breeding animal, they have a long lifespan and they can accumulate knowledge during this time. So from their own experience, from the experience of others, and they can store this information in their big brain. And then what's really important, and what we discovered as we started thinking about some of these amazing facts that these birds are able to do, is they make associations extremely rapidly. I mean, it seems like one trial, they try something, if it works, it's associated with a reward, they remember and redo that. And if it is associated with a bad experience, a punishment, a dangerous situation, they remember that and avoid that sort of setting the next time it presents itself. So what we're going to show you now is a drawing of the brain that Tony did within the head of a crow to give you some sense of how their brain is packed in that skull you just looked at. And it's just going to highlight a few of the sorts of information that can be integrated within the brain of the crow. So you'll see that there's a lot of sensory information that comes in through the eyes or the ears or the bill. And this is these form physical connections, the nerve cells, physical connections among parts of the brain that gather this information from the environment and that associate it with memory, with emotion, past experiences, and ongoing associations with others in their environment. So take a little look here at what the brain of a crow might look like. So it's not all the same. There are different parts of the crow's brain that responds to memory and emotion and other parts that form associations between these areas and specialized places where different sorts of environmental sensing is coming in. Some of it coming straight from the eyes like ours into different parts of that forebrain, others into to different parts of the brain. So one other look at the brain of the bird here will show you an image that indicates a bit about where the memory and emotional parts of the brain are. And a couple of keys to pick up on here are the hippocampus, which is where memory, just like in the human brain, the same area, it's called the hippocampus, stores spatial memory and perhaps important social memories. And the amygdala is located, and that's an area in the brain of the human as well as the bird that is a key to emotional significance. So the sense of fear and the sense of loss and perhaps goodwill is all felt in this part.
Not to mention anger.
And anger, for sure, yeah. So have a look at this for a little more detail, and then we'll get on to some interesting stories about how the birds put this brain to use. So the other thing we had on that image was something we call looping, or the ability to reconsider information. You saw information could be coming in through the bird's eyes, perhaps, as those dotted lines going up into the forebrain of the bird. And there it's considered and sends actions back down the spinal cord to the muscles of the bird to behave a certain way. That's the same way we do it. We take information in, we send information down to our muscles, and we do things. That's the behavior we're interested in. Well, what birds can do, as well as what mammals can do, is that information can come into your brain, and it doesn't have to go straight to your muscles. It can loop back into your forebrain and be reconsidered. The same neural places, the same neurons and connections among them that command the muscle to do something are again activated just by the thought of doing something, and you can reconsider and shape and refine those actions. Perhaps some planning for what you're going to do and how you're going to respond the next time a situation presents itself can be done by this neural looping of information. So it's not just information in and behavior out in us, certainly, and in birds either. It's information in, it might go out and make us do something, but it can go back in and stay in the brain and be thought about and reconsidered and shaped, can be dreamed about and influenced by processes at night as our brain is very active in sorting through important information as we sleep and as we dream about it. Same thing happens in birds that happens in our brain. Some different places, some the same, and the same chemicals that motivate us and are also found in birds' brains. So a lot of the stories now we're going to go into, we tend to relate to human stories because the brain of humans and birds has an awful lot of similarity. And a lot of the things we do, birds can do for the same reasons we can do them.
This next slide that we have is an indication of some of the looping you were describing, because the New Caledonian crow, again in the laboratory situation, has reconsidered its behavior many times and refined its response to a particular challenge, if you will. And in this case, there's some insight being applied because,
sure.
Well, let's take a look at the next slide and then we'll tell you what the bird is actually doing.
Yeah, see if you can put it together by looking at these different steps. All right, so what we've got here is what's called meta-tool use, and really I think the clearest demonstration of insight in a bird to date. And the three images that Tony had there, the first one of the bird pulling up a short string to get a small stick, that might be rewarding in itself if what you were pulling up was food. You'd be getting food closer to you with each pull. But in this case, it only got a small stick, which these birds had never been able to use for anything profitable in their past experiences with that setup, where they had just seen in their cage a small stick hanging from a branch. They'd pull it up and they actually quit doing it because it didn't get them anywhere. But in this experiment, they came into a room that had not only that small stick hanging, it also had that box in the center of the diagram, which was kind of a cage that had a larger stick within it. And they couldn't reach that large stick with their bill. They couldn't get it through the bars of that cage. And they also had one other thing. They had a clear tube, kind of like Betty was using, laying down, that they had to use a long stick to reach in and grab food. So imagine yourself, you're thrown into a room and you've got a small stick hanging, which has never done anything for you, a cage with a big stick in it, and a tube with food in it that, you look at it and you think, wow, if I only had that big stick, I could get the food. And that apparently is what these birds did, because as soon as they got in the cage, they didn't just go over and start rapping on the tube. They didn't make a tool. They went up and got the small stick, which in the past had never done them anything. They pulled it up. They used it to get the big stick out of the cage, and then used that big stick to get the food. And they did it on an average of 6 seconds. Once they entered that room, 6 seconds later, they had the food out. So they didn't sit around and try things. They understood the requirement to get that food right off the bat and went out and did it.
Speaking of sticks, this next image suggests that a crow realized what a stick was being used for and employed the same stick for the same purpose. Friend and colleague of ours, Russ Balda, down in Arizona, observed this at his bird feeder. A Steller's jay flew in to the feeder where a crow had invaded, and this time it brought along a stick and jabbed at the crow. It couldn't drive the crow off the feeder by itself. Well, in the process of jabbing the crow, it dropped the stick. The crow, being an enterprising bird, picked up the stick and jabbed the jay and chased it off.
Here's the image of it. So they can use sticks for multiple purposes, as weapons, perhaps even. And we've got other stories like that. We've had similar stories with ravens using sticks to get a great horned owl, a deadly enemy, out of their particular area. I think, to me, one of the most amazing aspects of these birds is their voice. And it certainly has engendered a lot of deep thought and speculation and interest by people about what in the heck these animals are saying, and the complexity of these vocalizations is truly amazing.
One thing you might add, John, is a little bit of information about the syrinx. We often think of crows and ravens having a voice box similar to ours. It's not similar. It's in a way far more sophisticated. You don't slit the tongue of a crow to get it to talk.
No.
It can do it independently of its tongue. And in fact, the syrinx is located way down in the trachea itself. And there are dual parts of that syrinx where it can produce two sounds simultaneously. So it's no surprise that they're capable of not just sounding like or mimicking, but imitating human voice as well.
Right.
In this example coming up, what about that one?
Yeah, I mean, it shows the power of a songbird. And we got to remember that crows and ravens are songbirds.
Right.
The raven is the largest songbird in the world. And that gives them two things. It gives them that complex syrinx that Tony mentioned and the muscles to warp it to make all kinds of noise. But it also gives them a loop in their brain so that when they hear something, they can remember it and reconsider it and refine it and produce a sound that is the same as what they've heard. That's what a songbird is able to do, learn its song. And we were really impressed when Kevin Smith told us this story from the University of Montana back in the 60s about a crow that had woken him up one morning. He heard his dog going crazy in the backyard. It was barking and lunging and making quite a ruckus. And this was like 5 or 6 in the morning.
Somebody was yelling, "Here, doggy!
Yeah.
Here, doggy!
Here, boy, come on, let's go!" Whistling, getting the dog all excited. So Kevin goes out to confront this stranger, and he doesn't see anybody. Nothing. Just the dog going nuts. And he gets a little closer, and from behind the kennel pops up a crow saying, here, boy, let's go."
Yeah.
Speaking in a perfect human voice, good enough to fool the dog for sure. And so Kevin was amazed by this. And the cool thing is that it just didn't stop there. This crow evidently flew around Missoula and would gather up dogs and bring them to the University of Montana campus. And these dogs would be chasing this calling crow, following their master's voice, so to say.
Here,
and,
boy! Here,
yeah,
boy!
lining up at a tree, and the crow would sit up in that tree and keep the dogs right there, keep their attention fully on him until till classes would change. And then the crow would take off through the students, and the dogs would all be following the crow, and they would perhaps dislodge a sandwich or a bag of chips every now and then and reward the crow. But it's so neat that he was able to use human voice in an appropriate setting to invoke perhaps a meal or maybe just the fun of tormenting these canines.
And here's a picture of the crow lecture. We've been fascinated with the whole idea of, like people, crows like to play. And in fact, crows receive endorphins just like we do when we play. It feels good. Clearly, there are good reasons to play. It's something that is often a non-threatening situation where a bird can pick up skills that it will need to survive as an adult. It is going to establish some kind of social position in relationship to the others of its species. But moreover, since they continue to play well into adulthood, there's something that's pleasurable.
And it reinforces some important neural connections.
Exactly. Yeah.
By firing those same actions, you're building strength in the ability of a stimulus to have a fast response in your brain.
And coordination.
Yeah.
In this next picture, you're going to see a bird in the Copenhagen Zoo that enjoyed playing with a ball, tossing it from beak to feet and back again.
So pretty neat ability there of a crow in a captive situation, maybe bored, decided here's something interesting it could do to enjoy.
Well, how similar is that, to a kid or an adult throwing a ball from one hand to the other? It's something to do, and it creates that coordinated
Yep.
move that is beneficial in just being able to operate in the world.
And the coordinated move, of course, is actually a script in the brain. It's a well rehearsed and well established connection among neurons. That's why they're able to do it, and that's what by playing you're building those connections in the brain.
And a lot of the play that has been observed, and a lot of the reports, by the way, that we're sharing in this book have come in from around the world. But locally, some of the things that have been observed is interspecific play.
Mm-hmm.
My experience with macaw, John, of course, was that he enjoyed playing with the husky that we had for a number of years, chasing one another through the woods, the raven typically initiating the chase by tugging on the tail of the dog. But in the case of some of the play between two different species, the cat and bird relationship has changed remarkably when you can have a crow pulling string across the living room floor and a cat in hot pursuit like we would to play with a kitten.
Yeah, Carolee Coffey sent in some video of this for us, but we're going to show you a still that Tony rendered of this pet crow of hers, Omar, teasing their family cat.
A great example came in from Colorado, where observers followed ravens as they retrieved shards of bark. And much like a surfer would use a surfboard on a wave, they used the shards of bark gripped in their four toes by flying into the wind and catching a wave or a thermal up against this cliff and rising into the heavens and back down again, over and over and over again. Again, using the bark as a tool, if you will, for play, to augment the play that they were engaged in. Take a look at this shot.
Yeah, just imagine coming up on a cliff and seeing ravens soaring, which is neat enough in itself, and then all of a sudden noticing, hey, they're not just soaring on their wings. So this play, as pleasurable and as important as it is to a bird in building coordinated action, sometimes leads to mischief, sometimes gets these birds in trouble. And we have gotten a ton of stories about how crows have made people's lives difficult. And there's really no end to this, because once these birds know that something of value to them is around you, they're going to do everything they can to try to get at it. And the first example of this is not just trying to get food, although we think some of this behavior, which is pretty common, the tweaking of another animal's tail, some of it may be related to trying to get food. It's not uncommon for us to observe eagles and ravens and crows interacting here in Western Washington on a salmon stream. And an eagle, much more large and powerful than a crow, might have a salmon carcass that it's eating. And a crow isn't going to just come up and go at the face of the eagle or the foot. It's going to sneak behind and tweak its tail just enough to get that bird maybe to turn, look away, and at that time another crow or raven can sneak in and grab the fish. So this example is of a kind of a scaled up version of that. It's one where the white-necked raven from Africa, a huge bird, not quite as large as the common raven, but a much greater bill. Look at the arc on this bill when you see it. It's huge. And that animal, it tweaked the tail of a meerkat that it was in association with. And why it did it? Maybe to get a jolt, or maybe maybe in the past it had gotten a meal that way from the meerkat. But have a look.
My time with the raven macaw was pretty instructional, if not inspirational. I often let macaw fly around the neighborhood every morning, and on one occasion, he got into some rather difficult straits. I would call him back with a whistle or a shout, and I would feed him as a reward for returning. He got really good at coming to my call. One day he came back. He'd been down behind some trees at the end of the street, and he brought a clothespin. And this was an age before clothes dryers. People would hang out their clothing for a couple of days if we had some warm weather here in Seattle, which was rare enough. But nevertheless, I took the clothespin out of his beak and gave him a handful of food. And that was pretty much it for the day. He'd take a dust bath and bathe and hang around. But the next morning, when I let him out, he took off like a shot out of a gun, disappeared behind the trees and really started whooping it up down there. Out of frustration, you could hear him, "Wak, wak, wak." And when I called, he burst out of the trees and came sailing down the middle of the road. In the next picture, you'll see what he had in his beak. Well, a raven stealing underwear is not an easily thing explained in my neighborhood. So I
Nor mine.
no anybody's, I suppose. And I timed the flights of the raven to be around days that somebody wasn't washing clothing.
Yeah, good medicine for sure. One of the other interesting mischiefs that we learned about and investigated involved a raven up in the North Cascades National Park, not too far from here. And this was a bird, for some reason, that decided it had a fascination with windshield wipers. And what it would do would land on the car and rip the rubber off of the windshield wiper, so that the visitors would, unbeknownst to them, come back to their car and not have a functioning windshield wiper. They could scratch their windshield with it, or worse yet, in a rainstorm, which is very common here, they would not be able to clear their windscreen from all the water and perhaps have an accident. So the Park Service invited me up to try to solve this problem and understand it a bit. And I went up there with all kinds of interesting ideas. I thought, oh, maybe they're gathering these windshield wipers and making a weatherproof nest, or maybe they're selling them on the side of the road to other interested Corvids. Who knows? But in fact, there was nothing really interesting they were doing with the rubber. They were just ripping it off and dropping it on the ground. But we thought, well, let's take advantage of these birds' abilities to make very fast connections among good and bad things in their environment, and try to teach this bird, who was named Hitchcock by the Park Service employees, to not steal windshield wipers. So my daughter and I lured Hitchcock and his mate down to some food, and we captured it with a net gun, which we typically use to catch birds for research. And it shocks them. I mean, it scares them. They're all of a sudden pinned down under a net. And we would then grab the birds and weigh them and measure them, and applied bands, unique colors to their legs, so we could identify them in the future. And we did all this by holding Hitchcock down on the windshield wiper of a car, so that we hoped that he and his mate would get the idea that it's a bad thing whenever I'm this close to a windshield wiper. And next time they either came into this area of the park, or they came across a windshield wiper somewhere else, they would immediately relive this experience. And this would cause them to stay away from the windshield wiper and not cause any more damage. The alternative, of course, was that the Park Service might have to remove this animal from the park. And nobody wanted to do that. And we hoped we could use its brain to teach it a lesson, rather than having to use violent force in this case. And it seemed to kind of work. The bird definitely reduced its use of the immediate area where the thievery had been occurring, and it tended to not take windshield wipers. But the Park Service also provided an important discouragement here. What they did is they gave people pieces of PVC pipe that they could stick on their windshield wipers, and basically allow a lot of windshield wipers to be inaccessible to the bird. So we reduced its accessibility, and we gave it a bad memory of the last time it was around a windshield wiper. And those two things together, we think, helped turn off that behavior in the bird.
This mischief matter is, we might accept in terms of crow behavior, is worldwide. And crows in Japan and places where the Shinto religion is practiced, where they have shrines, is inclined to steal candles. And that is probably explainable because of the tallow that goes into the candle. They're going to eat them. But when they fly out, the candles are often lit, and they've had a number of jungle fires as a result.
Here's an image of that. I like to use that example as perhaps one of the ways that some of our legends and beliefs came to be. An awful lot of Native Americans have in their legends somewhere that a raven or a crow brought light to the world. And perhaps by seeing this sort of thievery, where a raven would come in and steal an early human's source of light because it's a food source when it cools and forms a nice hard bit of fat for the bird, maybe that stimulated people to think, wow, maybe that's how indeed the sun and other major sources of illumination got into the atmosphere.
There are other examples of mischief, if you will. We've got images of cigarette smoking crows from Europe. Whether they're smoking it or not, they certainly retrieve the pack of cigarettes. They have seen the cigarettes in the mouths of people. They associate what we put in our mouth with the food that they can eat, and they're going to investigate. And here's an image of something that was observed.
And again, it's not so outlandish that they'd even pick up tobacco. Because they do have receptors in their brain, just like we do. They've got receptors that are stimulated by nicotine and even stimulated by cannabinoids in marijuana and other drugs. So they get the same sort of rush that we would get from using these substances if that indeed gets in their bloodstream and up to the receptors in their brain. A lot of the work I've done has been on how these crows in particular are able to recognize individual people and sort among good and bad people in their environment. We've done some experiments, which to me are the most interesting that I've been involved with in a long time, where we captured a few birds, much like we captured Hitchcock, but we captured crows on the university campus here, and we wore a particular mask when we captured them. We wore a caveman mask in this case. And what we did then was to test, did the birds respond to that mask when somebody else would wear it or the next time they saw it? And we compare it among different sorts of masks, lots of different ways to try to confuse the crow and see were they really paying attention to our face. And what we found was that, yes, they pay close attention to our face and they remember the face of the human that caught them. They also remember the face of humans that have cared for them and given them food and rewarded their behaviors. And they act differently to those two. When they see anybody wearing a face that has captured them in the past, they swoop down and mob and harass that individual, just like they harass a hawk or an owl. And they've kept this memory here on campus for almost 7 years now. It's still ongoing. I don't know if it'll ever drop out of their repertoire, but it really seems to me that it's strongly rooted. It's an emotional response. We've demonstrated by looking at the brain activity that it's an emotional response of a learned fear association between seeing this face of a dangerous person and having experience being captured by that person the next time they see it.
Well, why don't you relate the story from Sweden of a corvid remembering a face and taking revenge after it actually used a mechanism to gain access to their house?
Yeah, I think this is my favorite story. It was stimulated by a woman in Sweden hearing about the research we had done with crows and recognizing faces. And what she told me was that one winter in the suburb outside of Stockholm, she provided a little bit of food to magpies. And magpies are in the same family. And she liked having the magpies around. They were pretty and they had nice song and calls. And she was interested in helping them out through the winter. And that was cool. She gave them a little bit of food here and there, and the birds were around, and she enjoyed that. Until her doorbell rang one morning, and she went out looking to see who was at the door, because it was pretty unusual for that doorbell to ring, and there wasn't anybody there. But across the road were some magpies. And the same thing happened several times till finally she saw magpies on the doorbell. And I'll show you an example of this from a drawing that Tony did. But the magpies are perched on the tongue of the doorbell, which is actually the face of a lion. So these birds learned to ring the doorbell to get food. And they only did it when Inga, the woman, was inside. They wouldn't do it if they saw somebody else in there, especially if they saw her husband. Because the husband, Avi, he was not real keen on these birds being around. His culture is pretty similar to many Europeans, in that magpies are bad luck and they're thieves. They steal shiny things from you. So he didn't want these birds in the yard. And he told me he intimated at them that he was throwing something one time. And from that point on, the magpies took revenge. So not only did they ring the bell to get food from Inga, but whenever Abby would go out to get in his car, they lined up above it and they pooped all over his car, just filled it with crap. And the poor guy had to wash his windshield every
Pretty
morning
good.
to even get to work.
They were really zeroed in on that windshield, I gather.
Right on his side, on the driver's side only, and only his car. He'd move it around, try to switch places with Inga. Didn't work. Had to put up with the wrath of these magpies until they finally moved out of town.
Well, along with matters of wrath, people have observed what appears to be grief in corvids. And we've often gotten the question, do crows and magpies and other corvids have funerals? Well, it depends on how broadly you want to define the term funeral. But we do know that, that crows have emotions. The degree to which grief is part of that makeup is yet to be measured. But what we also know is that crows will assemble around a deceased compatriot, if you will. In a picture you're about to see, I observed a gathering of crows which were relatively silent. When you get 100 and so number crows out there in the trees, there's usually a raucous going on. But there was a kind of a faint murmur in the background as individual crows flew down to the road where another crow had been hit and killed by a car. They walked around it. They didn't touch the corpse, but they got a very good look at it, and each taking their turn and then returning to the trees. This happened for probably 20 or so minutes. What might be going on here, and John and I have discussed this off and on at some length, but not only is there an acknowledgement of the deceased that might have been a relative or a sib of some parent, but it's also an awareness elevating experience. What actually contributed to the death of this animal?
Right.
Is it threatening on this stretch of roadway? What
Maybe
can
I should remember that spot.
Yeah, what can I learn from this? What are my associates doing here? Does this change my social position in the group of crows that I'm a part of?
Right.
Is there an opening here? Is there a mate available even?
And certainly, again, these animals have the same sorts of chemicals in their brain that cause us to feel sad and loss. So it's not unreasonable that they would have those sorts of emotions. But we do know from lots of other examples of bird loss that if they do, it's pretty short lived. I mean, they remate rather quickly. The prime thing for these birds is to get out and breed again, and maybe take advantage of a new social opening, as Tony says. But they are not going to dwell on that for very long, in my opinion. They're going to get right to the business of improving their fitness and producing more young. And they don't have the luxury that we have, really, to be able to consider that loss for an extended period of time.
And yet, it's amazing, John, how these birds do appear to leave time in that whole day budget, if you will, for things like play, where they can devote in their crow affluence, I suppose, an appreciable amount of energy to kind of enjoying that dynamic of back and forth between the birds, or to chase a predator out of the territory, to really bring them, the collection of crows together, give a muster call from the crows to chase a predator. Of course, there's good reasons for doing that.
That's what I'd say. They have very good reason. They're gaining an advantage of getting a predator out, or they're perfecting a move that they may use in the future. So there's good reason, and there's good reason not to dwell on a loss like this for very long, because you need to move on, and you need to maybe still have a nest that season. I had a pinyon jay pair that I was studying in grad school that had been together for 12 years. And when one partner was lost, the other remated with another individual in a matter of days. So this was a long-standing bond by any animals, even our standards. And yet immediately it got on with the business of forming a new pair bond so that it could continue to breed that season, because it might have been its last season of breeding. And a bird or an animal under the force of natural selection can't afford to miss those sorts of opportunities.
The reasons for, of course, constantly applying their curiosity and investigating, and there are good survival reasons for that as well, testing things out. But when you think of some of these birds having kind of individual moments where they sing to themselves, and there's this kind of, that's not exactly a silent song, but observing both crows and Seller's jays, as I have, just simply sitting on a branch looking like they are well fed and singing and reflecting. I don't know whether it's like we're in a shower singing, but there seems to be a moment of well-being that they can suggest that they're doing something that's self-entertaining.
So these are the interesting things that come up. You can speculate about a lot of reasons that animals do these sorts of behaviors. I tend to think of it as pretty utilitarian. Maybe they're rehearsing song and learning and perfecting their particular calls in that case. But what we've tried to do here is lay out many of these sorts of behaviors which might stimulate creative thought about what could be going on in the brain of the bird, what's possible. We'll never know for sure what's going on there until we can communicate more directly with them. But we had some other interesting insights with respect to really the title of the book here, The Gifts of the Crow. And those gifts are many, many dimensional. Some of them for humans are just the ability to get close to another animal and observe another world. But some of them are quite literal. And the one that Gary Clark first told me about was one of these sorts of behaviors that a scientist gets, and you think, huh, there's no way this is real. But I got an email from Gary saying he had been feeding crows for a long time, and one day he went out, and as he gave these birds the food, which was a great prepared dish of chicken and all kinds of leftovers. I mean, Gary really goes about feeding his crows well. He took this bounty out, put it on the bird feeder, looked up and said, "Hey, I give you food every day and you never give me anything. Why don't you give me something?" And that day on his feeder was a small candy conversation heart from Valentine's Day with the word love on it. So I'll show you an image of that, and then we'll think about what could have been going on in that bird's brain. I can tell you what was going on in my brain was disbelief. It's like, no way, this can't possibly be true. And so we considered a variety of hypotheses from, that Gary was just trying to kid us to us being maybe seeing somebody kidding Gary and trying to pull a trick, and basically ruled out everything. And we were reconfirmed with so many stories of other people receiving gifts, not after talking, but after having performed a kind act to the bird, rescuing it or feeding it.
They also didn't get a Valentine with love written on it.
No. So this was unusual in this case, but it's not unusual for a bird that has a close relationship with a person, a crow or a jay or a magpie, to leave something shiny and interesting. Maybe one woman still holds, after I think 30 years now, a small blue Captain Crunch figurine that a crow gave her in her feeder one time. So people are really motivated by these sorts of gifts. And we thought, well, it could very well be that that these animals are using this association to kind of work their way into a good situation and keep people feeding them, keep them on the hook for this food. Or it could just be a mistake. They were carrying, for whatever reason, a blue Captain Crunch around, and when they got food, they dropped it. So it's hard to explain. It's hard to differentiate between those two alternatives, but it's certainly one or the other. And the fact that they bring gifts and leave gifts at places that are important to them is certainly not unusual from what we've learned.
But they also gift one another. Bringing, of course, food to the nest is one way of looking at a gift, but also decorating nests to some degree. And that may be functional as well. But why isn't it also functional to prime the pump a little bit and gift the hand that's been gifting you, if you will? So this is something that we've imagined and tried to describe in our book.
Right. Hey, we've got a question from somebody listening here that is asking about, again, feeding crows. They feed these birds every day, and sometimes when they come in, they caw, and they seem to be cawing right at this person. And it's interesting from the standpoint that we've seen this a lot. They'll caw. They may be cawing to get your attention, to put out more food, or more likely they're giving an assembly call to other crows to come in and join, that it's all clear and there's food out, because again, their lifelong mate or their offspring or other relatives may be close by, or others that they reciprocate, neighbors might be close by, and they have a very tight social group.
They do, and while the caw will be attractive to you, as John has pointed out, it's going to assemble other crows, so the possibility of getting some good chow. But we also have found that crows will take it one step farther and actually knock on the window to get you to come forward, or as in the case of the magpies, ring the doorbell. So they're going to get your attention one way or another if they think that you're going to come forward with something to eat.
Yeah. Another interesting question has come in about why do crows and magpies and ravens like shiny objects? And boy, it's a $1 million question. They certainly seem to. They gather them a lot, and they do carry them around and leave them behind. It's often the gifts that we heard about were shiny bits of glass that were left in feeders after they had visited those.
Probably for the same reason that we might like a shiny object as well. It's attractive in a sensory way. The eye is caught by it, and their innate curiosity is going to go over there and have them manipulate it a bit. If it's not a food item, they may well abandon it, but
Right.
it at least will get their attention, and they may hold on to it.
A cool thing to remember is that birds have not only exceptional sight, but they have a whole broader color palette than we do. We only deal with 3 colors basically: red, blue, and yellow. But crows and other birds have those palettes plus ultraviolet.
Ultraviolet.
So they might be seeing quite fascinating and stimulating signals coming out of a very shiny object because of the ultraviolet reflectance as well.
Well, while we wait for another question, one of the things that John and I explored was this relationship that we have with corvids and the possibility of having corvids for pets. And of course, currently the laws don't make that an easy thing. If you rehab birds, you may be able to keep a crow. But we thought that this great common accommodating species might be a good bird to have in company with you. It's different than a parrot. It certainly isn't that passive, easygoing, although they, of course, have very strong beaks. But the crow is hyperactive by comparison, and it's not the bird you're going to bring into the house and have it stay on one perch and allow you to find it in the same place that you left it. But this may be something, as in this next slide, that you might keep in mind.
So yeah, these crows will sit on your bicycle if you're a kid riding into school. They'll ride in with you. They'll wait for you to get out of school and accompany you home.
That kid had that crow every day.
Every day and it's still a very important fixture in his memory of what that bird did.
Say, John, why do crows dig?
Well, that's another question, and they're digging for food. A lot of times, I think what you see that they might be digging is actually they're caching, in that they take food that's abundant, like peanuts at a feeder or bread in a park, and they stash it in the ground and cover it and hide it from others. And then they have to dig that back and recover it. So you might be seeing them either going after natural prey like a worm, but more likely something they've stored in the ground and remembered that location where it's at and recovered it for later use.
And what a memory they have. The work with nutcrackers, the hippocampus expands during that period of time when they're caching seeds and when they're ineffectively kneading the seeds, so that they remember very, very well where that seed is. And in some cases, they will dig down under
a meter of snow.
A meter of snow.
Burrow in to get it. So even setting the angle right, not just burrowing straight down, but coming in at an angle to be able to get that food. So yeah, it's quite an amazing spatial memory that some of these corvids have, mainly the nutcrackers and pinyon jays that rely on these abundant but not very long-lasting foods.
One thing we might say about the caching is that it's one thing to put it into the ground where you remember it. It's something else again to put it into the ground where it appears that you cached it and then not cache it because you know that other crows are watching you and they will steal your cache. So crows and ravens and jays in particular will fake cache, if you will, if they think they're being observed by a bird that is known to be a thief of other caches.
Right, and they will move caches that they've already made if another bird who they know saw them make the cache is in the area, and that really gets at kind of the final characteristic that these birds may have, and that's what's called a theory of mind. They know what others are thinking about them. It's very difficult to prove. There isn't definitive evidence of it in animals, but certainly when animals do things that are different when they're around birds that have some knowledge that others don't have, it suggests they're kind of reading their mind, so to speak.
Well, what do you say to the guy who tells me that when he goes out of the house in an angry mood to see the crows and confront them because they're doing something on the farm, that they read his mind because before he can get back out into the yard with the shotgun, they're gone. What's going on there?
Well, they've learned this association for sure, and we don't know that they know that guy is planning on shooting them, but they probably have an association between a gun and something bad.
And his body language probably gave him away too, huh?
So one final question before we shut it down here. There's an interesting question here about crows having a sense of family, and is there a hierarchy within the social group? And so all the corvids are different in their social organization, but the monogamous pair bond is a real key. And crows also have strong, lasting associations with other generations. So some of their young from previous years will remain on the territory with the pair and help them raise young. So that's a real hierarchy there, I think, in that the pair bond is number one. The bond with other kin is probably number two. And then beyond that, there are associations with neighboring territory holders of crows and maybe those that roost together or flock and forage together. We just don't know anything about that greater hierarchy because to know it, we need to be able to identify all those individuals and see how they interact. And it just hasn't been done. But we do know that the family is a very strong bond, and especially the pair bond is very strong. So with that, I'd like to thank you for listening and discussing what we find to be a fascinating animal with you. And I hope you have good luck and see what we always say, see 12 crows at sunset, because that is a sign of good luck.
And we, when we have sunsets and it's not too cloudy, we do see the crows and make a point of doing so. Hope you do likewise. It's been a pleasure to join you.
Thanks a lot.